All right, we're looking at the 4.6 guided notes. Here we're going to discuss the domains and ranges and whether or not a relation is a function. And we're going to look at some quick ways to determine that. The entire set of numbers or elements that represents the input values. Oh, input values are called the domain. And the entire set of numbers or elements that represent the output values called the range. So here now we have domain and range, and this really goes into these are all of the values that would represent um, your independent variable, right, for your domain, and all the values that represent your dependent variable would be your range. Now it seems like we're calling the same thing a bunch of different names, but there's different contexts that we can say them in. Um, so I just want you to remember that the entire set of numbers, so all of the numbers collectively that make up your input values, that's your domain. So all of your x values is called the domain. All of the y values, that is your range. All right, so identifying functions using mapping diagrams. So here we're going to just take a few points and we're going to create a mapping diagram for each one of them. So it says identify the domain and range of each relation. Represent, oh, wow, it's a big time typo. There's a 4 in the middle of that. Represent the relation with a mapping diagram and determine if it's a function. The 4 shouldn't be there. That's too funny. All right, so again, domain are my input values, and this is a set. Remember, this is a set. So my domain, I want to say all my x values. So I just pick out all my x values. Here I have a -2, a 0, a 4, and a 5. I just picked out my x values from these ordered pairs. And now I'm going to represent my range as all the y values. So here I have a 1, a 2, a 6, and a 2. And now we're going to use this mapping diagram. Here, this is our mapping diagram. So here's my domain, and here's my range. I'm going to put my domain in there. So I have a -2, a 0, 4, and a 5. Over here I have a 1, a 2, and a 6. And now what I want to do is I want to draw a line that connects these guys. So -2 corresponds to 1, so -2 corresponds to 1. 0 corresponds to 2, so 0 goes to 2. 4 corresponds to 6, so 4 is going to 6. And 5 corresponds to 2, so 5 goes to 2. Now, let's go back. Remember, in order for this to be a function, now here we're going to determine if this is a function. So my next objective, once I've mapped it all out, determine if it's a function. Well, I know that it's a function if every input has only one output. And here, my input, my domain values here, they each go to just 1. So 4 goes to 6, 5 goes to 2, 0 goes to 2, -2 goes to 1. So over here, they all point to one guy over here. Even though 0 and 5 both point to 2, that's okay. That is a-okay. So let's try this other one on the other side here. My domain, again, I'm just going to list out my x values. Here I have a 6, a 4, 6 is already accounted for, and a 5. In fact, let me just write that in there. Let's write that, 6 and a 5. And here my range, a 5, a 3, a 4. I don't like the way that's writing here. A 3, a 4, and an 8. And I'm going to go ahead and set up my domain and my range in my mapping diagram here. So I have a 4, a 5, and a 6. And over here I have 3, 4, 5, and 8. And now we're just going to map them over. 6 goes to 5, so this 6 goes to that 5. So I don't need to worry about him anymore. And the next one, 4 goes to 3, so that 4 goes to that 3 like that. so I don't need to worry about him anymore. And 6 goes to 4. Let's get that guy out of here. So 6 goes to 4, like that. So that one's off the board. And 5 goes to 8. Let me get my last one out here. 5 goes to 8. Now, is this a function? Is this a function? Well, 4 goes to 3, that's fine. 5 goes to 8, that's good. But 6, my input here goes to 4 and 5. But that ain't good. That ain't good at all. So what I'm looking for is my domain is, do I have one member or one element of my domain pointing to two elements in the range? And here I do. So this is not a function. And I apologize. Over here we determined that this, yes, is a function. Okay, so hopefully you get the idea. Domain, list your x values in a set. Range, list your y values. Oh, there's my set. And then for domain, just list out your numbers. I try and do them smallest to largest. That's just me being a little pedantic, and that's okay. Alright, so let's cruise along here. So another way of determining if a relation is a function is the vertical line test. Vertical line test. That is, if any vertical line passes through more than one point of a graph, then the relation is not a function because one input has multiple outputs. So again, the vertical line test is a quick way of determining whether or not we have a function. So let's take a look at this guy here. We have 5 graphs. We're going to use the vertical line test and determine quickly if the following functions, if the following graphs are functions. So this first one here, can I draw a vertical line that passes through the graph of this circle and dot more than once? Well, sure. That vertical line has a point here, a point here. So this is not a function. Now, I'm going to take a line here, and what I'm going to do is I'm just going to use this like a pencil, and I suggest you use your pencil this way because this might be helpful. But again, if I could draw any vertical line, it could be anywhere along the x-axis like this. But if I draw a vertical line and it passes through more than once, it is not a function. But if it passes through that graph only once at every point along the way, so for this second graph here, I'm only crossing at one point as I pass my pencil over this graph like this. I'm only passing through one point at a time. So this one here, this guy, yeah, yes, that one is a function. Alright, so the last thing I want to discuss in this is the function notation. Function notation is extremely useful, especially if you understand what it's saying. So here, we've done a lot in terms of y equals something. So here we have y equals negative 3x plus 1. And here, this, we know it's going to be a line, and something that we can develop a table and graph it and look at it, and it would be nice. So now, what we want to do is we want to use function notation with this thing. So the first task says write a function using function notation. Well, here we say f of x equals negative 3x plus 1. Note, it used to say y equals negative 3x plus 1, and now I'm saying f of x. How is this read? Well, that's exactly it. We read this as f of x. And I want you to be very careful here. This is not multiplication, and I want to make this a very clear point here. This is not multiplication. So what my function notation simply says f of x, and that's all. Don't need to read anything more into it. This is not multiplication. This is not f times x. This is just my f function in terms of x. See, here's my input value. And so it says, can I use other letters besides f? Well, sure, we could have a g function. We could say g of x equals negative 3x plus 1. Or we could say g of x equals 2x minus 3. I mean, there's all sorts of things we could do here. And it doesn't even necessarily have to be f and g. We could say h of x or L of x. It doesn't necessarily matter so much. We don't want to say things like x of x. That would be kind of strange. But it's just naming convention. It's just saying that here I have an f function. Here I have a g function. Here I have an h function. So if we were going to use more than one function, we'd use more than one letter to describe those functions. But in general, for right now, we're only going to describe one function at a time. And here, the one function that we're going to describe is f of x as negative 3x plus 1. So now how can we use this notation to evaluate when x equals 2 or x equals negative 3 or x equals 5? Well, this is the neat part about function notation. This is why I like function notation so much. So if x equals 2, notice here's x, so I would say f of 2 equals. And notice I replaced this x with 2, so I need to replace that x with 2 as well. So minus 3 times 2 plus 1. And that's negative 6 plus 1, which is negative 5. Hey-o, that's a 3. Negative 5. So my x value is 2, and my y value then becomes negative 5. So what about f at negative 3? Well, I'd say negative 3 times negative 3 plus 1, which is 9 plus 1, and that is 10. So f of negative 3 is 10. And now we could look at f of 5. f of 5 is negative 3 times 5 plus 1, which is negative 15 plus 1, and that's negative 14. So f of 5 is, it looks like 44. Hold on, let's make sure. Negative 14. Again, this is not multiplication. I am simply using these parentheses to denote what my input value is. And so whenever I have f of x, then I want to have x in my rule. If I replace the x with a 2, then I want to put 2 in my rule and solve. And that gives me a point on the graph. All right, so the homework for this section, I want to do, this is going to be page 271, and I want to get 8 through 15 all, and then I want to do 18, 20, 24, and 25. Alright, so here's our homework set. And if you have any questions, again, we're going to do some of this in class. So bring your questions to class and get ready to go.